All right, our next example with trig identities is another simplifying problem. And this one's going to involve some fractions and combining fractions. Okay, so this is another big type of problem that we're going to be solving. This one says simplify sine theta plus cotangent theta cosine theta. If we think about, our menu of strategies, remember these types of problems, there's not necessarily a set, process. You have to do this, that, or the other. It's kind of like a puzzle, and you have to use strategies to solve the puzzle. This is what we came up with yesterday. We can use trig identities whenever possible. Sometimes we're going to factor the expression to help us. Change things to sines and cosines is one of the strategies, and those are the three that we really hit on. The fourth one that I'm going to put in here and that you should add to your notes is, add or subtract fractions. Add or subtract fractions. If there are fractions there, we may just need to add those fractions and combine those to make things, to make our expression simpler. Okay, so that's the fourth one. So we have all those now. So if we think about those strategies, and you're looking at this and you're saying, all right, what do you want me to do here? Okay. Well, there's definitely no Pythagorean identities that we're going to be able to just substitute. Okay, there's no squared in there. There's no sine squared. Nothing there. It doesn't look like we can factor anything, right? Changing things to sines and cosines. That's where I would start. So I would simply say, all right, well, this cotangent, let's just change that to sine and cosine. So that'd be the first thing I do. I would say, all right, sine theta plus, and now we substitute in here. Remember, what is cotangent? Right? What is cotangent in terms of sine and cosine? That is cosine theta over sine theta. Remember it back in the unit circle, it's x over y. It's cosine over sine. So we substitute that in, and then we kind of see what happens here. Okay, so now we look at this and we say, okay, did that help us at all? We were hoping maybe something cancels off really nicely, but it doesn't. So what do we do here? We're going to take this right here. We're going to take these fractions, and I can think of this as like cosine over 1. And let's just combine those fractions. When we multiply fractions, we can do that. We can multiply across. So I change it to sine and cosine. Nothing really exciting happens, but we want to multiply these fractions. Let's combine those. So this is going to be sine theta plus, now if I multiply cosine times cosine, right? That's cosine squared theta. So that's going to become cosine squared theta. And if I multiply the bottoms of the fractions, sine times 1 is just sine. So this becomes cosine squared over sine. All right, so now we're at this stage right here. Right? We change things to sine and cosine. We multiply the fractions. Now we're stuck at this stage, and we're still trying to simplify this. We think of all the strategies in our head. Right? Is there any Pythagorean identities that jumped out? No, that didn't really happen. There's no factoring we can really go ahead and do. But we do have fractions that we can add. This is really our only option here. Sine theta over 1, let's put over 1 there, plus cosine squared over sine. We have two fractions, and we're just going to combine these fractions. Really, this is our only option. Okay? So, a little review on fractions, right? Off to the side here, right? Let's just do a really simple example just to review. If I have, let's say 2/3, and I'm going to add 5/6, right? When we add or subtract, we need a common denominator, right? We kind of did a bunch of this with the unit circle and when we're dealing with fractions in general. We don't have a common denominator, so we need to multiply this fraction by 2 on the top and bottom. So therefore, this can become 6, and we have a common denominator. So this would finish with, 4/6 plus 5/6. Now that we have that, we can write this as one fraction, with the bottom being 6, which is the common factor, and then this becomes 9/6, right? And then we can reduce that even, and we can go from there, okay? So think about how you add normal fractions with just numbers. And now back to this, right? If I'm right here, and I'm saying, do these have common denominators? No. So how are we going to add the fractions? Well, what does this fraction need that this one has? This one has a sine theta. This one does not have a sine theta. So it's going to be as simple as multiplying this fraction by sine of theta, but also the top by sine theta. We're doing that so that we get a common denominator. Get common denominator. Right? So we multiply that. Okay, then we rewrite this. All right, so let's go ahead and what's the result of that? Well, if we multiply on the top sine times sine, that becomes sine squared theta, and then on the bottom here, sine times 1, well, that's just sine now, sine of theta. Let's bring down what we had from the red part, right? That's cosine squared theta over sine theta. All right, we're getting somewhere. Trust me. Okay, some of you might be, some things might be popping out at you right now. We have common denominators, right? Sine and sine. So therefore, we can combine these fractions. We can get rid of the addition. The common denominator is sine theta, and the top is sine squared plus cosine squared. Say that again, sine squared plus cosine squared. Hopefully something's popping in your head there. Sine squared plus cosine squared over sine of theta. Well, going back to our strategies, doing this whole puzzle, right? That should jump out at you because that's a Pythagorean identity, right? This right here, sine squared plus cosine squared, is always equal to 1. X squared plus y squared on the unit circle is always equal to 1. So that is something that is going to help us greatly now. We're going to say, all right, this is really going to break down because sine squared, cosine squared, well, that's 1 over sine theta now. That's 1 over sine theta. That's all it is. If we want to take that a step further and we don't want to have any fractions, you could say your answer is 1 over sine theta, but what is 1 over sine theta? Well, you could say, well, that is cosecant theta. So my answer here, and this is a clear case where this really breaks down. Okay, it kind of starts off a little slow, and you're like, what's going to happen here? We go through our steps. We say, let's switch things to x's or switch things to sine and cosine, and then we decide, all right, we're going to have to let's try to add these fractions. We add the fractions, and then boom, Pythagorean identity comes out, and then you can immediately put that puzzle piece right in there. You can substitute that. That becomes now a 1 over sine. Now there's no addition in the problem at all. And the end result is cosecant theta. So this is a classic example of taking one of these, trig identities and breaking it down to something really small. But we have to combine fractions in that whole process. So that's a big part of it.